Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass and I am with Open Systems Media, specifically with embedded computing design. This week, my guest is Jonathan Hacker. He is the CTO and the founder at TeleCANesis. Did I say that right, Jonathan?
Yeah, you said it right.
Perfect. How you doing today?
I'm doing great. How are you?
I'm doing just fine. Thank you very much. So the audience may not be familiar with telekinesis. So what is it that you guys do exactly?
So we're building a system integration platform for making safe and secure connected devices.
That's about as vague as you could possibly get.
Yeah.
Go down a level there for me. What are you actually doing for your customers?
Yeah. So, I mean, in embedded development, a lot of time you're spending a lot of time on doing signal routing, protocol integration. So interfacing with CAN buses, hooking up to MQTT endpoints, and many other ways, right? And the traditional, I mean, a very common way of doing this is, by writing that code, but writing the code manually leads to bugs, delays, all that. So we're coming at it from a different angle. And that angle is leveraging a lot of automated code generation.
Okay, I really want to get into that topic of automated code generation, but you made the comment of manual coding can lead to bugs, and I can make the argument that automated code writing leads to bugs. Why is it? Why is one better than the other?
So what you can, when you're doing automated code generation, by following basically templates and things like that, you can generate code that follows the rules in general. So there are over the years of software engineering, we've established a good number of best practices. So it's not all, certainly please don't think that I'm talking about taking the human out of the equation at all. Like, I'm sure we could possibly talk about AI and how AI versus code generation and that sort of thing. I'm not talking about that at all. So I'm just talking about the fact that when you're doing a lot of this integration code, a lot of it is about messages, and the messages are well defined. They're well defined from the beginning, and if you can take those definitions and use that to generate a lot of the repetitive code, I mean, there's mountains of repetitive code in order to get these systems talking to one another.
Okay, if you could see me here, you'd see that I'm writing down all kinds of questions based on all the stuff that you just said, and
Yeah.
And I do have a whole bunch. But first, let's level set. When you're talking about code, I'm doing air quotes around code. What is it
Yeah.
you're talking about? Because that could be anything.
So we're talking about the code. So if I'm reading signals off a CAN bus, it's got certain byte order, certain pieces of information that have to be extracted. So that's some code. There's code where I need to take that, put it together in a particular format, send it to another system, and because we're talking about today we have the systems are a lot more heterogeneous. So you might not just be talking about embedded device, but that embedded device might need to send that information to a cloud server, or maybe you're controlling it from your phone. Maybe it's being collected in a data center for some reason, and that's a lot of steps for things to get lost, mistakes to be made. So what we're taking, the approach is a message-based approach, looking at the messages that have to get from one place to the other, and taking that and generating endpoints for everywhere where you might need to use that data.
Okay, a lot of what you're describing is available as open source. Why wouldn't I just go to some repository, pull it down, and stick it into my system? Why do I need to generate it from scratch?
So in a way, it's actually about I mean, there are plenty of very good open source projects out there, but putting them together in a safe, secure, and reliable way that you can trust is that's the challenge. And so that's what we're doing for you. Is yeah, we're basically following by taking the code generation approach. We're so the code that we're generating, we're running that through its paces, right? And so the stuff that I mean, the code that's coming out at the end of the day is it's in a verifiable and certifiable state, right?
Okay. Somebody had to teach these engines how to properly code. So does that mean that these engines are only as smart as the people who develop them?
Well, that's true of all code, right? So right now we have certifiable and verifiable code out there in the wild today, right? That has been in automotive autonomous vehicles, the space program, nuclear reactors. We've actually been using code generation in the periphery in these industries for years, and that's how these industries have ended up with certifiable and verifiable code. In anywhere where it's a safety is a critical matter of life and death.
Okay. So you brought this up earlier, and we certainly have to talk about it. Why wouldn't I use artificial intelligence to generate my code?
Well, in
You knew
general,
I was
it
going to
is.
ask this, right?
Oh, of course. Yeah, I mean, the problem in a word is trust, right? AI is what AI can generate is often it doesn't have yeah, I mean, AI basically, generates. I mean, it'll generate you a lot of code, but it's not generating based on templates. It's generating based on its guess of the right. I know I'm colloquializing here, but yeah, I mean, the problem is that we don't trust AI, and so I mean, in general, we have to go through this verification process. But because of the less direct way, like, in code generation, it's these things are based upon deterministic templating engines that we understand, and we know that they're following the rules. So it's it's not to say that you can't verify or certify AI generated code, but by using code generation or a templating engine, the burden is reduced because it's generating what we call certifiable or verifiable code.
Okay. One of the battles that we fight on my side of this equation all the time is that people want not they want, but people are generating the type of content that I provide with AI tools. And I could tell you straight out, it's basically crap.
Yeah,
And there's I can tell when somebody sends me an article that's been generated by AI. Is it the same thing on your side of the fence there? Would you be
absolutely.
able to
Yeah.
look at code and say, "Oh my God, you're not really planning on using this, are you?"
Yeah, I mean, like our developers are no strangers to AI, and looking at what comes out, they often get into arguments with, hey, you did this completely wrong, right? Like it's often generating code that is just, yeah, it's like you said, complete nonsense, right? It's very difficult to trust when it makes so many mistakes all the time. And then somebody might say, okay, well, AI just has to get better, right? But I mean, like at that point, you still have to verify and you have to verify everything that's coming out, right? So there may get to a point where AI is doing a lot more of the work, for this. And that's also not to say that we don't have a thought of using AI along with this, right? Like there's a couple cases where AI might be very usable. For example, if you were to pull an existing code base into telekinesis, AI would be fantastic at taking that apart, analyzing it, and figuring out how to fit it into the telekinesis tooling, right? So that's a great thing, and um, you know, also anywhere where you're not dealing with code that needs to be safe and secure. I mean, you could possibly use it as a bit of a armchair.
Mhm.
Almost like pair programming, except you're pair programming with a computer program instead of a human, right?
Yeah, I'm a big believer in everything that you just said, and I also believe that there will be a day when it'll be able to do my job as well as I could do it. But I can guarantee you that day is not today, and that day is not in my professional future, I don't think. But we'll just have to see what happens.
Yeah, hopefully we'll both be retired by that point.
Absolutely, absolutely. Thank you very much, Jonathan. This has been enlightening and interesting, and I hope to hear more about it from you.
Okay. Well, thanks for having me, Chris. Rich, sorry.
That was Jonathan Hacker. He is the founder and CTO of TeleCANesis, and I am Rich Nass with Embedded Computing Design.